Next chapter, coordinates and graphs. So far, we know how to represent a point on a number line, but that is only limited to a unidirectional point. Any point on a flat surface or plane is represented using at least two coordinates, indicating the distances from a reference point. A Cartesian plane is found by simply combining two number lines perpendicular to each other. The point of intersection is called the origin and it's represented conventionally by O. This is the reference point. Distances are measured from here. The horizontal number line is called the x-axis and the vertical one is called the y-axis. The axes have arrows indicating that the numbers increase to infinity. Values on the right and those above the origin are positive and are increasing as you move away from the origin. Values to the left and below the origin are negative and decrease further along. To be able to easily locate and define points, the Cartesian plane is usually drawn on a graph paper. The graph paper has large square boxes and most of them are divided further into 5 or 10 small squares inside each large square. But this one of mine has only the large ones, but it still work. A point is represented on the Cartesian plane as xy. That is the number of points moved along the x-axis from O and the number of points moved along the y-axis, again from the origin. Now let us see how we plot points on the Cartesian plane. Now before plotting points, there is a fundamental rule about the Cartesian plane: the consistency of the scale. If you decide that one big square represents one unit, then that has to be consistent until the last number. However, you can still use a different scale on the x-axis from the one you used on the y-axis. For instance, on this Cartesian plane, one square represents one unit on both axes. If you decide that two squares represent one unit on any of the axes, this is still correct. The important thing is to be consistent. To plot points on the Cartesian plane is pretty easy. We've said that a point is represented as xy. The first digit represents the number of points moved on the x-axis from the origin. The second one is the movement on the y-axis. For instance, let's plot these points: M21, N33, and O51. For M, we move 2 points on the x-axis on the positive side because it's positive 2. And again, we move 1 point along the y-axis again on the positive side. So this is the point M. N, we move 3 positive points on the x-axis and again we move 3 points on the y-axis, so this is N. Finally O, 5 points on the x-axis and 1 point above here. Now if you join the 3 points, we have a triangle. We said that the triangle has been represented on the Cartesian plane. Now again, let's plot the points P, -4, -2, Q, -3, 1, and R, -1, 0. P, we move 4 points to the left on the x-axis, that is on the negative side, and again we move 2 points down on the y-axis on the negative side, so this is P. Q, we move 3 points to the left of the origin, that is on the negative side of the x-axis, and again we move 1 point on the positive side of the y-axis, that is above the origin. Finally R, we move 1 point on the negative side of the x-axis. Y-axis is 0, so we do not move any point, so this is R. Now notice that R lies on the x-axis because there is no movement along the y-axis. That's another triangle represented on the Cartesian plane. Now, having known that, let us now move to linear graphs and see how we draw them. Now, consider an equation like this one. X plus y is equal to 6. From this equation, we can find an endless number of values of x and the corresponding values of y that will satisfy the equation. Now, I'll have x and y here, and then I'm going to choose random values of x, and I will calculate from the equation, or rather I will substitute in the equation to find the corresponding values of y. So let me have 0, 1, 2, 3, 4, 5, and 6. You can take a long list of numbers. And then y here, what will be the corresponding values? Now, when x is 0, what will be y? If x is 0, so I substitute 0 in x here. So I'll have 0 plus y is equal to 6, and that means y will be 6. If x is 0, y will be 6. What if x is 1? So I substitute here, and I have 1 plus y is equal to 6, and then y is equal to 6 minus 1, and that gives me 5. Proceed. When x is 2, I write 2 here. 2 plus y is equal to 6, and therefore y is equal to 6 minus 2, and that will give us 4. You write 4 here. Then 3. When x is 3, we put 3 here. 3 plus y is equal to 6, and therefore y is equal to 6 minus 3. That gives us 3. Continue. 4. When x is 4, we have 4 plus y is equal to 6, and therefore y is equal to 6 minus 4. That should give us 2. When x is 5, we shall have 5 plus y is equal to 6, and therefore y is equal to 6 minus 5, and that is equal to 1. Finally, when x is 6, 6 plus y is equal to 6, and therefore y is equal to 6 minus 6, and that should give us 0. There we have our list of the values of x and the corresponding values of y for the equation x plus y is equal to 6. Now, the next thing, we take the corresponding values of x and y and write them as coordinates. And so we shall have the first coordinate 0, 6, then 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, and 6, 0. If we plot these points on our Cartesian plane, let's see what we have. These are the points. Now if you join them, you realize you are drawing a straight line. This is called a linear graph. All equations in x and y are linear, provided that x and y are not squared or cubed or raised to any power greater than 1. That is to say, y squared plus x squared is equal to 20 is not a linear equation. Linear equations can be interpreted into linear graphs, and because the graphs are straight lines, you only need 2 points and all the other points will fit in automatically. Now, using the same knowledge, let us try and plot this graph. The equation is 2x plus 3y is equal to 6. Now we choose any value of x or y, negative or positive. Now this time let me try working with values of y. So I'm going to choose random values of y, and then I will calculate from the equation the corresponding values of x. So I will have -2 and 0. So when y is -2, what will be the corresponding value of x? So to solve that, I will substitute -2 into my equation wherever there is y. So I'll have 2x plus 3 times -2 is equal to 6. Now I have 3 times -2 is -6. So I will have 2x minus 6 is equal to 6, and therefore 2x is equal to 6 plus 6, that is 12. X is equal to 6. And so when y is -2, x is 6. Using the same equation, let me find the corresponding value of x when y is 0. We do the same, substitute 0 in the equation in the place of y. So we shall have 2x plus 3 times 0 is equal to 6. 2x is equal to 6 and x is equal to 3. And so when y is 0, x is 3. Now write them as coordinates. So we shall have the first point 6, -2, and the second one 3, 0. Now plot the 2 points and join them. You can make the line as long as you want, and that's how we draw linear graphs from linear equations. Now when you plot a graph, you need to write its equation on that line. So this was x plus y is equal to 6, and this one was 2x plus 3y is equal to 6. Now consider the x-axis itself. Along that line throughout, the values of y is 0. The equation of the x-axis is y is equal to 0 because all the values of y along the x-axis are 0. For the y-axis, the equation is x is equal to 0 because all the values of x along the y-axis are 0. Always keep that in mind. Later on in Form 2, we shall see how, given a line, you can derive its equation. Finally, graphical solutions of simultaneous linear equations. Previously, we solved simultaneous linear equations using the substitution and elimination methods. I promised you there was a third method of doing that called graphical method. When we solve simultaneous equations, basically what we are doing is finding a point where the values of x and y will satisfy both equations. In simple language, the solution of simultaneous linear equations is the point of intersection of the two lines representing the equations. So we simply draw the two lines and the answer is the coordinates at which they intersect. For example, let us solve these two simultaneous linear equations using the graphical method. X plus y is equal to 12, x minus y is equal to 6. So all we need to do is to draw the graphs and find the point of intersection. So we plot the points first. For the graph x plus y is equal to 12, I want to choose two random values of x and then calculate the corresponding values of y. I'm going to choose 5 and 6. So when x is 5, y will be 5 plus y is equal to 12, and that gives us 7. When x is 6, y is equal to 6. Right. So we have the first 2 points, 5, 7 and 6, 6. We plot the points and draw the line. This graph is x plus y is equal to 12. We move to the next one, x minus y is equal to 6. I'm going to choose two random values of x and then calculate the corresponding values of y. I'm going to choose 6 and 8. So when x is 6, y will be 0. When x is 8, that is 8 minus y is equal to 6, that is y is equal to 2. So I have the next 2 points, that is 6, 0 and 8, 2. I plot the points and then I draw that line. That graph is x minus y is equal to 6. The two graphs intersect at 9, 3, and therefore x is equal to 9 and y is equal to 3. That is the solution of the simultaneous linear equations.
One of the wonderful things about mathematics, I think, is that people are impressed. It's often seen as a very hard subject, and so if you've done math, it's often treated as an entrance requirement, as a credential to do lots of other things. And so one idea is that for example, some MBA programs, the only thing they require going into it is a good, solid math understanding. They can teach you all the business. They just can't teach you the math fast enough. And so I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as a filter or as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad, because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.